Okay, so now we've covered the basics of R, and now we need to cover some basics of computer math with a focus on computer math necessary for data science. And we're going to do that with R as well. So the topics we will cover are sets, logic and truth tables, and probability. So we'll start out with sets. And of course, most of us have studied sets before. We just want to do it with R as well. So we'll talk about the definition of a set, subsets, cardinality, which just means how many elements are in the set, equality, union, intersection, complement, empty set, algebraic properties. Set operations for probability will be a bit different from the same as set operations for vectors. So R has set operations for vectors in the base package, but we'll have to rewrite a little bit for our purposes. So later we'll develop our own function that will be oriented towards our goal of doing probability. So please let me know if you don't understand something. So a set is just a collection of objects, and that always bothered me because then what's a collection? But anyway, we use this definition. So the objects in the collection are called the elements of the set. So examples would be the set of senators in the United States Senate, and we'll be using a data frame that has this as its contents. The set of outcomes when tossing two coins simultaneously, and the set of all dogs with an IQ of more than 200. So this is an example of an empty set, almost certainly, right? I don't think there are any dogs that have an IQ of more than 200. And notation, for example, the typical way of indicating sets would be something like this. Suppose we're talking about the set of all integers between -2 and 3 inclusive. That could be denoted like this. And also we're going to talk about what are called Venn diagrams. So these are 3 examples of Venn diagrams. This is Venn diagram. Each circle here represents a set, and this box is called the universal set. And here again we have a universal set and 2 sets, and here we'll call them A and B. And here we have an indication of what's in each set. So for example, in set A we have 1, 5, 8, 10, 6, 7, 9, and 12. And in set B we have 2, 3, 4, 6, 7, 9, 12, 13, and 11. So we will talk about the intersection of A and B as having these elements in it. And we can draw a Venn diagram for 3 sets. And in that case, like this part in here is the intersection of A, B, and C. Anything that's in here is in all 3 of the sets, and so on with the other places. We can talk about something out here is in the intersection of the complement of the 3 of them. So like I said, cardinality of a set just means how many elements are in the set. And in set notation, we would use something like this. N of A would refer to the number of elements in the set. So if A equals this set, then the number of elements in A would just be 3. So here's something in R. This, you should recognize this as a vector. So it has the elements 1 through 8, and then cat and dog. And if we ask for the length of A, that means how many elements are in A. and it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so that's 10. So the length is a function which tells you how many elements are in a vector. Okay? So if we want to define cardinality for this set A, now A is a vector, but it can also in some ways be thought of as a set, but we have to be careful because sets, if you repeat an element in a set, you will get we say the set only contains one of each of those elements, even though they're repeated several times. So the number of elements won't be affected by how many times you repeat the element in the set. However, it definitely will be affected here. So if you so we have to be careful of that. And cardinality we could define as simply we could define a function called cardinality, and we could simply define it, the cardinality of A is just the length of A. Notice here I didn't put a return here, but this is a very simple function. You don't need a return here. It'll just give us back the length, and this is all written on one line. It's okay to do that. So if I check this, the cardinality of A, it's just going to be 10. But we have to be careful. So I'm going to ask you to write a function which does not, which is more careful than this one, and doesn't, if A was equal to 1, 8, comma, 1, 8, comma, cat, comma, dog, that would mean the length of A would be 8, and 8 is 16, 18, but that's not what we want for the cardinality. Okay, so here's another problem that we might want to, that we'll need to deal with. So here, suppose that A is equal to this, and D is A, comma, n of A concatenated. So D has, so the cardinality of A is 10, but I didn't print out D here. But if I printed out D, it would be 1 through 8, then cat, then dog, then NA. So if I do the cardinality of D using our current function, I'd get 11, because I added in, this NA will actually be counted. Okay, so we may not want that either. So one way to deal with that is to try something like this. So let's look at this in RStudio and see how this works. So I'm going to stop the video here, and I'll start with a new video where we're going to look at this in detail.